Hello and welcome to the Engerati studio. I'm Rose Bundock, Head of Commercial Content. I'm joined now by Jay Giri, former Director of Power Systems and Strategic Initiatives at GE Grid Solutions.
Yep.
Welcome, Jay. I believe you're now an independent consultant.
Yes.
40 years in the power sector. So we're going to spend some time talking about grid assets and asset management. Obviously, we were just talking off air, you were talking about the last 10 years being quite chaotic. And utilities are still trying to protect their grid assets, still trying to stay, keep the power on, and we've got renewables. Your frame of reference is the US. What are you seeing in the US? How well are utilities managing that integration and while protecting the grid?
Okay, in some ways the US grid is vast, and so it has an inherent resiliency built into it. So the grid assets are a little more protected than in other countries. So we've seen in Europe, and we're learning actually from Europe, like from Ireland and from Denmark, where they have a lot of renewable energies, how they manage the grid assets under this scenario of high renewable penetration. So really in the US what has happened is there is an added emphasis on resiliency, which is both physical and cyber because of superstorm Sandys and things like that, and also flexibility to allow different people to get into the grid. So the mantra in the original was reliability, security, and efficiency for the past 30, 40 years. And now we've added resiliency and flexibility to be able to accommodate. So in that regard, I mean, in order to protect the grid, the US has embarked, the government provided some funding to install synchrophasers, which is phasor measurement units, which instead of measuring the grid every 2 to 4 seconds, as we have done with SCADA from the beginning, the PMUs measure data at a sub-second rate. So they measure voltages and currents. So that is an initiative which was started by the US government saying, how can we protect the grid better in the future after the 2003 blackout? And they talked about situation awareness being lacking, and so how can we improve that? So synchrophasers and PMUs is one technology that is being deployed, which is being still finalized and tested, because unless you trust the data, you're not going to make decisions on it. So that is one way. And the other way is adding more intelligence to the lower voltage distribution system. Like ever since the beginning, the transmission system was the focus of reliability and security because you got the biggest bang for the buck. If you had a secure transmission system, you served more customers. But now there is a greater emphasis in adding intelligence to the distribution in the low voltage system. So that is helping the transmission grid assets as well, because as you make the distribution system more independent, then the transmission system is also helped. So the other change we're seeing is along the line, the resiliency is microgrids. So there's a growth in microgrids where it could be a university campus, it could be a naval shipyard or whatever. And GE was involved in a number of those projects where a microgrid is basically a renewable resource, generation resource, with some kind of storage and a load. And essentially they can operate independent of the grid. So they do not need the transmission grid at all times. So for the majority of the time, they can operate as independent grids. In fact, you're going back to the old days of Edison when we started the grid. It was a microgrid, and which gradually became an interconnection. So that is another way we're seeing microgrids and synchrophaser technologies and things like that are really helping maintain the security integrity of the overall grid.
You mentioned cyber resilience. I mean, that's obviously being taken quite seriously now. Is every US utility gearing up for that scenario, that malicious threat?
Well, they need to if they're not, because at least the major utilities are, because there is a mandate from the government about identifying what are your cyber assets which are critical. So you call them critical cyber assets. So once an asset is deemed as a critical asset, then you have to ensure and prove that it's being protected in the right manner from cyber attacks. So not every asset in the grid is deemed critical, but certain substations and certain generating plants and certain distribution entities could be deemed as critical assets, and in that case you have to demonstrate and prove that you've developed proper cybersecurity procedures to protect that.
So when can we expect to see an actual real-time grid when it's actually operating on real-time data?
Well, right now we operate at a 2 to 4 second rate. We're monitoring, and we issue controls at a much slower rate. So it's a very slow sort of feedback. But with synchrophases, you're going to have much faster measurements. And now we're looking at thyristor-based controls like SVCs and TCSCs and fax devices and DC, which can be invoked very quickly. So coupling synchrophases, sub-second measurements, with the sub-second thyristor devices, you can make the grid now a little more self-healing, meaning you can actually start getting the human out of the loop and making it sort of like a self-healing. It detects a disturbance and it recognizes it and then it corrects it. So the good thing is if you can contain a problem, disturbances will occur in the grid at all times. I mean, each time you switch a light switch on and off, you created a mini disturbance. So the question is, can you contain that disturbance without propagating it or allowing it to cascade? And that is where I think the microgrids help, and also the new technologies like PMUs and thyristor control devices will help.
We're here in Turkey. There's 21 distribution companies here, most of which now have SCADA systems. Mm-hmm. Obviously, they've got ambitious smart grid plans. Is there a way that Turkey can leapfrog some stages that other countries have gone through to get to that kind of real-time goal?
I think the problem with distribution systems in general is they're not that well monitored, meaning you don't have devices on them giving you real-time information. So the first step could be to increase the monitoring capabilities, whatever it may be. It could be a PMU, it could be RTU, it could be any transducer, and then to bring it back to a central site, to the distribution company. And then you can automate the distribution system. So things like ADMS, an automated distribution management system, or IDMS, integrated distribution management. So these are all products which are offered by vendors with the goal of monitoring the distribution system better and also controlling it within itself in a more independent manner. So I think right now the way I see it is there are 18 whatever distribution companies. They'll have to develop their smart sort of technologies and controls first, and then they can start talking to each other and then maybe helping each other. And that's the way I see the future going.
Thank you, Jay. Thank you for your insights. Thank you for joining us. You've been watching the Engerati studio. You can watch plenty more of our videos on our YouTube channel.